In the last video, we talked about geometric series and how to calculate them if there's a finite amount of terms. But what happens when there's an infinite amount of terms? So what we want to look at first is the difference between divergent and convergent. So a divergent series is where our common ratio is greater than 1. And when this happens, our values are all going to approach infinity. So they're going to get bigger and bigger and bigger, or they could be negative. They could also approach negative infinity because they could get smaller and smaller and smaller. So an example of this, if we have 1 plus 2 plus 4 plus 8, etc. Let's go ahead and just plot these on a graph. So for example, this would be our first term. So our first term is 1. Our second term is 2. Third term is 4. Fourth term is 8. Our fifth term ends up being 16. And you can see if you are used to exponential functions, that's exactly like what this would be. This is going to go up, 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 up forever. Because of this, if I keep adding bigger and bigger terms, I cannot actually calculate the sum because it's just going to go to infinity, okay? So when we have a divergent series, we can't calculate the exact sum, again, because it would just be infinity. Now, convergent, on the other hand, this is when our ratio is less than 1 and the absolute value is less than 1. So we're looking at values between -1 and +1. And these are actually going to approach 0. So again, let's just look at a graph before we talk about this more. In this case, our first term would start at 1. And then our second term would drop to a half. Our third term would be a fourth. Our fourth term would be 1/8. And if we kept going with this, we're going to get smaller and smaller values as we go, but we're never going to cross this x-axis. So that means that all of these values are getting closer and closer and closer to 0. And what's good about that is as we get closer and closer to 0, these numbers become almost insignificant. So I can actually calculate the sum of this because at some point we're just going to say that these values equal 0. So let's get into the formulas for these. So the sum for an infinite amount of terms is going to be our first term divided by 1 minus our common ratio. And we can only do this when our ratio is less than 1 because, again, this would make it a convergent series, so approaching 0. And the reason why this formula works, if we look at our finite series, right, this was the series we came up with for regular geometric series, then if I plugged in infinity, so if I wanted to find S infinity, I would get U1, 1 minus r to the infinity over 1 minus r. And remember that in this case, r would be a fractional amount, right? So as my fractions, as the denominator was getting bigger and bigger and bigger, this value was getting closer and closer to 0. 1/2, 1/4, 1/8, all closer to 0. So we end up saying that U1, 1 minus, if we went out forever, this becomes such a tiny number that it's insignificant, so we just put 0 in, over 1 minus r. And then that's how we get our formula. 1 minus 0 is just 1. So then we just have our first term over 1 minus r. So let's look at a couple of examples for a geometric infinite series. So in this case, we have 2/7 plus 4/7 plus 8/7, and these dots indicate that we're looking at an infinite amount of terms. So first we want to see if this is a convergent or a divergent series. So I'm going to find my common ratio, which we get from taking the second term divided by the first term. So I would have r equals 4 over 7 times the reciprocal 7 over 2. So we get 4 over 2, which is just 2. So because r equals 2, this means that it is a diverging series. It goes on forever, so we cannot find the sum. So this is divergent. and we can't find the sum. All right, let's look at the next one. So again, we need to find our common ratio first. So we would have -1/6 divided by 1/3. So we would have -1/6 times 3/1, which is -1/2. So this time we have r is -1/2, which means the absolute value of r is less than 1. So this is a convergent series. So we can indeed find the formula. So let's go ahead and do that. We would have S infinity equals U1, which is 1/3, over 1 minus R. And we can go ahead and put this into our calculator, and this comes out to 2/9. So our sum of infinite number of terms in this series would be 2/9. Let's look at one more for a word problem. So for this one, a ball is dropped straight down from a height of 5.5 feet. With each bounce, it rebounds 75% of its height. So we want to find the total distance it travels until it comes to a rest. So let's first start by actually writing out this series a little bit. So we're starting with 5.5 feet, and then we know it's going to rebound to 75% of its height. So we're going to multiply by 0.75, which is 4.125. And we could do that again to get the third term, which would be 3.09375. So our common ratio is actually given to us. So our ratio is 0.75, and 0.75 is less than 1, so this is a convergent series, which means that I can find the sum. So we're looking for when this ball ends up coming to a rest, so basically when it gets to 0. So we're going to use our formula, which is U1 over 1 minus 0.75, and that comes out to 22. So the total distance it's going to go is 22 feet before it comes to a rest. So in this video, you learned the difference between convergent and divergent series, the formula for the sum of an infinite convergent series, again, we can't do a divergent series, and how to apply that formula. Thanks for watching.